here with a new problem, and the problem name is N-ary tree level order traversal. So let's see the problem, and then we see how we can solve it with different approaches. Okay, so in the given problem we have a given N-ary tree. What is the N-ary tree? We can also call it as a generic tree, right? And what we have to do, we have to return the level order traversal of its node values. So N-ary tree input serialization is represented in the level order traversal, and we have to give all those values in level order. To understand it more clearly, let's see an example. So in binary tree, each node has at least two child, but in N-ary tree, it can be more than two, or it can be one, or there will be no child. So let's suppose in that case we have two child, and this has three child, and this node has one child. So what we have to give? We have to give the output as, let's suppose I put some value 1, then there is 2, 3, 4, 5, 6 and 7. So output should be, we have to give an array of array, and each array contains level order. So this is level 1, which contains 1. This is level 2, which contains 2, 3. This is level 3rd, which contains 4, 5, 6 and 7, and that is what the output we have to return. Now it is a very easy problem, and anyone can solve it. I will prefer you that you have to first pause this video and try it yourself. If you are not able to do so, you can come and see how we can solve it. So let's see this example. So in this example we have this type of generic tree, and in this generic tree we have 1 as the root node, and this root node has 3 children, and this 3 node has 2 more children, and that is the output as I tell you. So whenever we have these type of problems, most probably we are going to use queue. But how we are going to use queue? In binary tree, if you solve this level order traversal problem, there is a very simple approach. We are just pushing things inside the queue, and we very well know that each node has 2 child, so we can simply say go to left, go to right, simply push inside the queue, and similar work we do. But in this case we don't have 2 child, it can be 2, 3 or how many it is. Now how we solve this problem? So let's start by using queue. So let's suppose we push 1, right, and then we will pop that out and store it in some array, and this 1 is a root node, and we will explore all its children, which is 3, 2 and 4, which is 3, 2 and 4, and then we again pop 3, right? But the thing is, we have to make sure that after which value our one level is complete. What I mean by this, if you take this example, in that case, if we take 1, this is level 1, but by using this approach we are not able to track that where the level completes. So in order to do this, we have two things. The first is, what we can do, after each level we can add some identifier. What I mean by identifier means some value which is unique of all the expected values, such that when that value comes in, we can identify, yeah, the level is complete. So let's suppose in starting we have root node, I just push 1 and also push -1, right? And now I start pop from the queue until and unless I get -1. When I get -1, in that case we come to know that one level is complete, right? And that's how we are going to refill our array. Now let's see this approach, how we can solve it. So this is our final answer array where we are going to push each level, and this is one of our temporary array. So what we do, we will pop 1 and push in this. Now what are the children of 1, which is 3, 2 and 4. Let's push this 3, 2 and 4. Now we will go for next element, which is -1, and that is a unique identifier. When we get -1 and our temporary array is not empty, in that case what we do, we first take this array and push in our answer array, right? The next step what we do is, we push -1. Why? Because we get one level completes, it means we explore all the parent node of the above level and its children, right? And this -1 signifies that these are all the values which is present in the next level. and also we have to make sure that this temporary array is empty so that we can refill it. Now let's go to the 3. Let's push this 3 inside this temporary array. And what is the child of 3, which is 5 and 6? Okay, let's push 5 and then 6. Now let's go. There is 2. Let's push 2. There is no child. For 4, there is no child, so we don't push anything. And when we here we can see there is -1. It means that level is complete. Now what we have to do, we have to check this temporary array is not equal to 0. Yes, it is not equal to 0. So we have to take these values, push in our answer array, and we have to push -1 so that it defines that this is our next array, and we have to make it empty. Great. Now let's go on. There is a 5, nothing. There is 6, nothing there, and again we are getting -1. In that case this is not empty, so we are going to push it inside our answer array, and also what we have to do, we have to make it -1, and also we have to make it empty. Now we are going to go and we see -1, but in that case our temporary array is also empty. It means we end up by traversing this and we return this array. So this is the one approach by adding a unique identifier. What should be the next approach? Can we do this without using that identifier? Yes, of course we can do it. How we can do it? We can simply for each level, whatever the values we push, we can simply get the size and we will traverse around. Okay, let me explain that. Let me write one more. 1, 2, 3, 4, and this is 5 and this is 6. So what I mean by size, so let's suppose in my queue I push 1 initially because that is the root node, and when I start pop things from the queue, I first check what is the size of the queue. So size of the queue is 1. It means in my first level there is only one element, so I will make sure that for one time I will pop things from the queue. So for the one time I pop things from the queue and push it in another temporary array. So we pop 1, push it in, set this, and what also we can do, all the childs we explore, which is 2, 3 and 4. But we don't go and pop this because right now we have only size 1. So it means we only have to iterate for once. After we iterate one element, we will push this inside our answer array. Okay, and we will again check the size of the queue. Now this is out of queue. We have 3 size queue, so we will update this 3. We will also make it empty, and 3 times we will pop things out, which is 2, and 2 contains 5 and 6 as an child. 2 is removed, then we remove 3, then 4 because they don't have any children, and size is 3, so it's all done. And we will take 2, 3, 4 and push here, which is 2, 3 and 4. Right? Now what we do, we again check the size. Now in our queue the size is 2, we will write it, iterate 2 times, 5 and 6, no child of 5 and 6, right? And we will again push this inside our answer, right? And at the end of the day, when we try to iterate other, the queue is empty. And that's how we are able to do a level order traversal of N-ary tree. I hope you get it. What is the time complexity? So time complexity is, so what we are doing here, we are going and we are traversing each node, right? So for the time complexity is vertices into edges, total number of vertices into edges, because we are going to traverse each vertices and edges. And I hope you are able to understand this problem. If not, you can comment out, I will surely help you. And let's see the code now. So here I am coding the second approach. You can also do the first one. So in the first one, second approach, what we will do, simply we push the root node and we get the size. We have a temporary array, and we will basically iterate inside the queue until our size is not equal to 0. We will take out the element, right? We will append it inside our array, and then we will traverse each child element, put it inside the queue and decrement our size. At the end of the day, we are pushing that temporary array inside our main answer array, and that's how it works. So thank you, and bye.